Okay, good morning dear students. Welcome for the physics class. Today we are going to discuss about the centripetal acceleration and the centripetal force. And this is the last concept in your motion in a plane chapter. Okay, after this concept, this chapter, the fourth chapter is going to complete. So let us start with the centripetal acceleration. Let me draw a diagram here. Okay, it's a circle. So this is a circle. I mean circular path. So the acceleration in case the particle moving in a circular path is called as the centripetal acceleration. Okay. So if any particle, any object is moving along the circular path, then whatever acceleration will be producing in that body is called as the centripetal acceleration. Okay. So let me consider a circular path here. Okay. And along the circular path, I consider a motion of a particle. Okay. So let me consider a particle will be here at a position A. Right? Then this particle is moving along the circular path, and whatever acceleration is produced inside the particle is called as centripetal acceleration. Okay. And one more thing, this centripetal acceleration is always acting along the radius vector. So in the last class I have said that radius vector means it is the line joining the particle moving in a circular path with the center of that circular path. So if it is a circular path, so I consider the center of this circular path here. Okay. So it is O, and line joining this center of circular path with the object which is moving in a circular path is called as the radius vector. And here the centripetal acceleration is always acting along the radius vector. It will be in this direction. So I want to say specifically that the centripetal acceleration will be in this direction. So always acting along the radius vector. Centripetal acceleration. Okay. Let me write those terms. So the first one, the definition of centripetal acceleration, that is the acceleration in case of a particle, moving along the circular path, the acceleration in case of a particle moving along the circular path is called as centripetal acceleration, and this can be indicated as A subscript C. Okay. And it always acts along the radius vector. Okay, always it acts along the radius vector. So here consider the circular path, and initially the object will be at position A. Okay. So after some time interval dt, it will displaced from its initial position A to B. Just consider this as a position B. Okay. So here, look. So object has been displaced from the position A to B. So here it is R, radius vector, and it is also radius vector R. And here, what it indicates? It is the angle described by the radius vector. That means it is the angular displacement d theta. Angular displacement d theta. Okay. Then here I draw a dotted line from A to B, straight line from A to B. What it indicates? It indicates linear displacement, and I will denote it as a dl. Okay, linear displacement dl. D theta is the angular displacement. Here, whatever linear displacement we are having dl and whatever angular displacement we are having d theta, that is going to happen in a small interval of time dt. I'll consider the time during which these two displacements happen as a dt, time interval dt. Okay? Right. Now, I'll just consider one more thing. The direction of velocity at point A, the direction of the velocity of the particle at position A, and the direction of velocity at point B. Okay. If you want to tell about the direction of velocity, already we have discussed that point. Along any curved path, if an object is moving, and at any particular point, if you want to say about the direction of velocity, then at that point we need to draw the tangent, and that tangent is going to indicate the direction of velocity at that point. Okay. So here, at point A, the direction of velocity will be like this. So it is the tangent which I have drawn at the point A. So here, it is the velocity vector. This line, the tangent, indicates the direction of velocity. So I will consider that as a velocity vector at point A. And here, at point B, I will draw one more tangent, and what it indicates? It indicates the velocity vector at B. Vector B means the velocity vector at point B. I hope you understand. Okay. So just call it as a diagram 1. That is figure 1. And next, I just need to draw these velocity vectors from this diagram to one more pattern. So look here, as you can see, this is the direction of the velocity vector at point B. So I draw it separately. So how can I draw? Here, this is the direction of the velocity vector at B, or else the velocity vector at point B. So I draw it separately. Look here. Okay, it is what? It is the velocity vector VB. Then VA will be in this direction. Okay, in this direction. So now I draw that here. So it is vector VA. Vector VA. And in which direction the velocity is changing? So initially the direction of velocity is like this, and here the velocity is like this. Okay. As the particle moves along the circular path, the velocity direction is changing in this direction. Okay. The velocity will be changing in this direction. So here I draw a dotted line in order to indicate the change in the direction of velocity. So this is, I will write 2. So whatever you have explained in figure 1 and 2, I need to write it in a description. So here, in figure 1, consider a particle moving in a circular path. So we have considered a particle which is moving in a circular path, whose radius is r. Okay. So circular path of radius r. Is it clear? Okay, with constant speed. So I am not using the constant velocity. Here I am saying the constant speed. Because here the direction of velocity is changing, not the magnitude. Okay? So speed is having only magnitude, not direction. So here the magnitude is same, the direction is changing at every point of the circular path. Okay? So that's why I say the constant speed. With the constant speed, the particle is moving. Okay? Consider a particle moving in a circular path of radius r with constant speed. Okay? With constant speed. It is the first point. Next. So here, VA and VB are the velocity vectors at the point A and B respectively. Let VA and VB are velocity vectors at point A and B respectively. VA and VB are the velocity vectors at point A and B respectively. The next we have dl and d theta are the linear and angular displacement in a time dt. Okay? Linear and angular displacement in time dt. Okay? So these are the things which we have taken in the diagram 1 or a figure 1. In figure 2 what we have? So here figure 2 represents, why I have drawn the figure 2 or the second figure? In order to represent the change in the direction of velocity. Okay? So here figure 2 indicates or it represents change in the direction of velocities of the particle which is moving in a circular path. So figure 2 represents change in the direction of velocity of a particle moving in circular path. Okay? And now, from diagram, you can say from figure figure, you can say, look here, the diagram or the triangle AOB, the triangle AOB and the triangle, write it as PQR. Are not similar? Yes, these two triangles are the similar triangles. So, if you turn this triangle in this direction, if you turn this triangle in this direction, in the right side direction, you can observe the triangle PQR and the triangle AOB are the similar triangles. Are the similar triangles. So, from the diagram, you can say that. Okay. So, triangle AOB and triangle PQR are similar. Similar triangles. Okay. So if we have the similar triangles, then we can write the ratio of their sides will be equal. So here I take AB divided by OB, which is equal to, so in the place of AB we are having R2, and in the place of OB we are having R2. So which implies, what do you mean by AB? AB means DL. DL divided by OB. OB means R, which is equal to R2. R2 means what? The change in the velocity, dV. Change in the direction of velocity, or you can simply say the change in the velocity. Change in the velocity, and I am not going to write any vector symbol. Okay, dV. And RC means the velocity vector at point P, so I will just write it as a V. Because the magnitude of VB and VA is the same. So that's why I will use the constant speed term. Okay. So without considering the direction, I just write only the magnitude. So both magnitude are equal, so I write it as a V. Okay. So then, which is what? DV is equal to, so you have to bring it to V in the side. So that is V divided by R into dz. So next, how will we define the acceleration? The acceleration means the rate of change of velocity with respect to time, dv by dt. So here, the centripetal acceleration means it is the acceleration of the particle which is moving in a circular path. So that's why, therefore, centripetal acceleration, that is AC, which is equal to dv divided by dt. So we can call it as equation number 1 and it as equation number 2. Okay. So centripetal acceleration, the rate of change of the velocity, dv by dt. So just substitute equation 1 and 2. Equation 1 and 2. Substitute equation 1 and 2. We get. So look here, AC is equal to, so again the differentiation of the velocity by dv. Okay, already dv is equal to d by r into df. Right? So in place of dv I am going to keep these values, but here we can introduce the differentiation. So I take out the constant terms from the differentiation. So here V is only the magnitude of the velocity. Here the magnitude is same. Speed is constant. The magnitude of velocity is constant. It is same at every point. So it is not going to change. So it is a constant. So I will take it outside from the differentiation. And next, divided by R. Radius vector at all the points of the circular path, R value remains same because it is radius of that circular But when it comes to DL, it is variable. So DL, right? D by R, DL is equal to dV, and we have here dV term. Okay? DL means what? That is linear displacement. dV means the time, dt is the time, charge here, okay? So dV is the time in which the linear displacement is happening. So this term is going to indicate the rate of change of displacement with respect to time. Displacement by time we have here. So displacement by time means velocity. Okay? So that implies AC is equal to V by R into dF by dt means one more V. So V into V is V square divided by R. V square divided by R. Because dF by dt is equal to V. I hope you understand. Okay? So here, this is the expression for the centripetal acceleration. The centripetal acceleration. Okay? Next, centripetal force. Okay? So centripetal force, we will write it as FC. So which is equal. Normal force, how can we write? Mass into acceleration. Force is equal to mass into acceleration. So centripetal force means mass into centripetal acceleration. So that is mass into centripetal acceleration. Okay? So that implies Fc is equal to m into centripetal acceleration is V square divided by R. It is an expression for centripetal acceleration. Okay? So this completes your fourth chapter, motion and plane. And I think I have already given you the notes. So very soon I am going to conduct a test on this chapter. So be prepared. I'll announce a date very soon. Okay?